All right, so here's our first example. It is practicing changing from radians to degrees and degrees to radians. So if in A you have 170 degrees and you want to find it in radians, a couple of important things that are noted here. It says find an exact measure and approximate value. Anytime it has an exact measure, if you're going to have pi in your answer, you're going to leave pi in your answer. You're not going to put it into your calculator. An approximate number, you're going to put all the values into your calculator and get a decimal. So as far as our exact measure here, well, if we have 170 degrees, we found out on our chart that 1 degree was pi divided by 180. So 170 degrees we would multiply by pi over 180 because we know that one degree was pi over 180 radians. That was from before. So if we have 170 degrees, we would multiply that by pi over 180. And this is 170 pi over 180. You could leave your answer like that. You wouldn't have to simplify it. If you wanted to simplify it to 17 pi over 18, that would be fine. And if we want to figure out what the decimal answer for this would be, we'd type in 17 pi over 18 in our calculator, and this is approximately 2.97. Part B. We're given an angle. It's a negative angle. Just like degrees, negative angles in standard position start at your positive x-axis and go in a clockwise direction. We're going to go and try and draw negative 12 pi over 11. Some things that are going to help us in drawing that. Okay? First of all the way around the circle is 2 pi, which is approximately 6.28 radians. Halfway around a circle is pi, which is approximately 3.14 radians. We want to go negative 12 pi over 11. Can you see that that's a little bit more than 1 pi? Because 12 over 11 is a little bit more than 1. In fact, it's sometimes nice to write the fraction in front and pi at the end. So you can think in terms of pi. If we're going in the negative direction, we'd be going this way. You need to go, here is 1 pi, right? 11 pi over 11 would be 1 pi. And then you need to go a little bit more. This would be that angle, negative 12 over 11 pi in standard position. I mean, if you wanted to be exact, you would have to divide this second half into 12 equal sections. And you need to go 11 equal section. And you would have to go 1/11 more. Well, the pi next to it just means that whatever number here is getting multiplied by pi. If you type that into your calculator, 12 divided by 11 times pi, to find out what that is, that's negative 3.47 radians. Okay? So the hard part, and one of the things that you're going to run into issues sometimes when thinking about radians, is we often talk about radians with pi in it as an exact number, and we don't often talk about radians as just a number. So negative 12 pi over 11 is negative 3.47 radians. And that means we have to go a little bit more than 3.14 to get there. So if we think in numbers, we can see why we have to go a little bit past 3.14 to get to 3.47. When dealing with a fraction of pi, now we realize that pi is halfway around the circle, 2 pi is all the way around the circle. My fraction here, 12 over 11, is 1 and a bit. So I need to go 1 and a bit around. 1 is halfway around and a bit more. If that fraction, so if I take the same 1 over 11, and I did something like, do it in a different color, negative 17 over 11 pi. What quadrant would that end in? Well, I would go here, which would be 1. Can you see that 17 over 11 is more than 1.5? Okay? Because if you changed 17 over 11 to a mixed fraction, it would be 1 and 6/11ths, right? And since it's a little bit more than half, that angle would go once around, once 1/2, and then a little bit more than half there. So I'll give you an idea of how to think about taking radians and drawing them. Now, if we wanted to change that to the nearest tenth of a degree, well, using what we had before, we know that 1 radian is equal to 180 over pi degrees. If you're going to memorize these, you can easily mix them up, because you can see how one is 180 over pi and the other one's pi over 180. So a couple of things to help you remember them. One is you can always derive them. Start with what you know. You know that there's 2 pi in a circle. You know there's 360 degrees in a circle. Divide both sides by 2, and you would say, I know that pi radians is 180 degrees. Then if I want to find out what 1 radian is, I need to divide both sides by pi. So that's one way that you could get that, oh, 1 radian is 180 over pi. That means 1 degree is pi over 180. So maybe that helps you remember which is which. Another thing that can help you remember which is which is thinking of our triangle. Remember how we had an equilateral triangle with 60 degrees? And we said 1 radian is if that gets squished a little bit, just a little bit less than 60. Do quick rounding. Think of pi as 3. What's 180 divided by 3? 60. That's close. That's 1 radian, what 1 radian is close to. So that can be another way you can remember this. So now we want to change this radians to degrees. We have negative 12 pi over 11 radians. Each radian is 180 over pi degrees. And so when we multiply this out, what happens to the pi's? They cancel out. 12 times 180 divided by 11 is 196.4. Was it to the nearest tenth that they wanted? Yes. Good. A shortcut for changing from radians to degrees that works if there's pi. Can you see that every time you'll have a pi, they'll cancel out? And since pi is equal to 180 degrees, what some people use as a shortcut, I want to change negative 12 pi over 11 into degrees. I just change my pi to 180, and that'll work every single time. Yes? Yeah. And part C. Given theta is 7.5 radians, change it to the nearest tenth of the degree. So we would take 7.5. We know that 1 radian is 180 over pi. So we would multiply by 180 over pi. 7.5 times 180 divided by pi. 429.7 degrees. Questions 4, 5, and 7.